In this tutorial, we are going to talk about solving equations of logarithm and exponential, as well as logarithm inequality and exponential inequality. So let's begin our discussion with solving exponential equation. So the first question which I have here with me is 4 raised to the power x minus 2 raised to the power x plus 1 to be equal to 48. Now, initially, when you have 2 raised to the power x plus 1, when we're talking about exponential, for them to add the powers, meaning the bases were the same, meaning it was 2 raised to the power 1 times 2 raised to the power x. So if the bases are the same, we add the power. So it was 2, then x plus 1. So I have to reverse it. I take it back to this. So I'll replace this with that. Okay? So I'll say it is 4 raised to the power x minus 2 raised to the power 1, then also times 2 raised to the power x to be equal to 48. The next thing what I'm going to do is I'll just write this and say it is the same as 2, then in the brackets I've got 2, then 2 to the power x is equal to 48, like that. When I reach at this point, since I have got now, initially I was trying to make these things to be the same, to have to the power x to the power x. So what I'm going to do is I'm going to let y to be equal to 2 raised to the power x, meaning I need to make this guy 4 to be the same as 2 to the power x. How can I make that? So it's going to be 2 raised to the power 2 now times x is 2x minus 2 open brackets 2 raised to the power x, like that. I need to have the same thing so that I make a quadratic equation. So now where there is 2 to the power x, let's replace it with y. So it's going to be y. Now since there is 2 there, so it's going to be, it's the same as, let me do this guys to make you understand. This is basically the same as 2 to the power x, okay? Then everything again raised to the power 2 minus 2 to the power x is equal to 48. So now where there is 2 to the power x, replace it with y. So it's y. Now since it is squared here, I'll say y squared minus, now here is going to be 2. Where there is 2 to the power x, replace it with y is equal to 48. Now this is a quadratic equation. Shift 48 to the other side. Y squared minus 2y minus 48 is equal to 0. So let's have the product to be negative 48, the sum to be negative 2. What will be the factors? Now we start thinking. So if we are to start thinking now, the numbers, which when I do times, they will give me 48. Then in plus, they will give me, okay, what will be those numbers? So if I don't really find the factors, it's possible I can use quadratic equation. Yeah, I can use quadratic equation. It will be easy for me. So it will be easy for me to do that. So it's 8, negative 8 and 6. If I do negative 8 times 6, so negative 8 and positive 6. This and this is negative 2 times 48. So since here the one having square, the factor is 1. Okay, let me just do it the way you know it. I'll have 8x. We are dealing with y. I'll have y, then plus 6 x or y minus 48 is equal to 0. Factor out y, it will be y minus 8 Here I'm going to factor out 6. So I'll have y minus 8. So I have got y plus 6 and y minus 8 is equal to 0. Meaning y is equal to negative 6 and y is equal to 8. I've got two values of y. But one thing should come in your mind is that we just had to rate y to be equal to 2x squared. So where there is y now, we are going, so we have got 2x raised to is equal to, the first answer we have found negative 6. So what I'm going to do now to find the value of x, I'm going to introduce ln everywhere. I'll introduce ln because I can't make the base to be the same, so I'll introduce ln. So it will be ln 2x is equal to um, is equal to ln negative 6. But you can't have ln then negative, so it's not possible. So this one is not part of the solution. I'll leave it. Okay. The reason why I was trying to introduce ln, I was trying to find the value of x. So when I introduce ln, I'm supposed to drop this to be in front. You are going to see how I'm going to do it for 8. So y is equal to 8. So now y is equal to negative 6. This is not part of the solution. Unless, let's try now the other one. So it's going to be 2 raised to the power x is equal to 8. We can make the base to be the same in this case. We're going to have x then 2 raised to the power 3. So x should be equal to 3, which is true. So this is the honest part of the solution. So the other one, the reason why it has failed, after I plugged in negative 6, we are saying this is 2 raised to the power x is equal to y. So y is now negative 6. I've introduced ln both sides. The reason why I'm introducing ln because I can't make the base to be the same. So I have now ln 2 raised to the power x is equal to ln negative 6. You can't have ln negative, it's undefined. So therefore, this one doesn't work. So the only solution is x is equal to 3. So you can use the same method. Now allow me to solve. I'm going to solve 2. You can solve this one. It's the same method actually. So the next one is 2 raised to the power x plus 1 minus 2 raised to the power x plus 1 then plus 1 is equal to 2 to the power x. What does it mean? If there is plus, meaning it was 2 raised to the power 1 times 2 raised to the power x minus same as this one. Then again 2 raised to the power 1 and 2 raised to the power x plus 1 is equal to 2 to the power x. So what I'm going to do is now I'm going to make things simple. This is the same as 2 then 2 to the power x minus 2 to the power x. Okay, 2 to the power x like that plus 1 is equal to 2 to the power x. Okay, now you're going to discover that these two things are the same. So this can cancel out. This is going to be 0 and I'll end up having 1 is equal to 2x. But now the bases I can't make them to be the same. I'm going to introduce ln. So it will be ln 1 is equal to ln 2x, ln 2 raised to the power x, ln 2 raised to the power x. So ln 1 is 0 because ln, regardless of any base, ln 1 is 0. Log 1 is also 0. So it's going to be, this is going to give me ln. Now I'm going to drop the power. So it will be now, the property of log allows me to shift the power to be in front. X ln 2. Okay, I want to make x as a substitute formula, divide both sides by ln 2. Even here ln 2. So x will be equal to anything as long as on top there is 0, this is 0. So x is equal to 0 in this case. So we can try this. We try if indeed we are going to get the answer is going to be the same. So if x is equal to 0, what will be the answer? So if x is 0, meaning, no, I've made a mistake. This was to the power 2. You have seen, right? Let me redo it. I had to put x only. So it is 2 raised to the power 2x plus 1 minus 2 raised to the power x plus 1 plus 1 is equal to 2 to the power x. I didn't include 2. I didn't say it. So now this is the same as 2 open brackets 2 to the power 2x, yes, minus 2 open 2 to the power x plus 1 is equal to 2 to the power x, like that. So now when I reach at this point, I can shift this guy to go to the other side. Or before I do that, I'm going to say let y to be equal to 2 raised to the power x. Meaning, if this is going to be 2y, because it is squared, so it's y squared, minus 2, where there is 2 to the power x, I put y, plus 1 is equal to y. Shift y to the other side, it will be 2y squared minus 2y, then minus y plus 1 is equal to 0. Then that is going to be 2y squared minus 3y plus 1 is equal to 0. So the product is 2 times 1 is positive 2. The sum is negative 3. What are the factors? Negative 2 and negative 1. Yes. So what I'm going to have now is I'm going to have 2y squared minus 2y plus, minus again y minus plus 1 is equal to 0. Let's factor out 2y. I'll have y minus 1. Even here I'll factor out negative 1. I'll have y minus 1 is equal to 0. So I'll have 2y minus 1 and y minus 1 to be equal to 0. So I'll remain with 2y minus 1 is equal to 0 and y minus 1 is also equal to 0, meaning that y is equal to 1 for the first one. The next one, if I shift 1 to the other side, it will be y is equal to 1 over 2. After finding this, these are not the answers. They're just going to help me to find the values. So what I'm going to do is I'll say y is equal to, we have said x to 2 to the power x is equal to y. Where there is y, let's put now, I'll start with half. 2 raised to the power 2 raised to the power x, we want to find the value of x, will be equal to y is half. I cannot make the base to be the same, but it's possible, right? Yes, it's possible. I can make the base to be the same, meaning it's going to be 2 to the power x is equal to 2. I can make this 1 over 2 to be 2 to the power negative 1. Okay, so the base can cancel, x is equal to negative 1. Then, now, after finding x to be equal to negative 1, I'll go ahead and now plug in 1 where there is y. I'll say 2 to the power x is equal to y. Where there is y, put 1. I cannot make the base to be the same, I'll introduce ln. Ln 2x to the power that is equal to ln 1. Ln 1 is 0. The property of log allows me to shift the power to be in front, so it will be ln 2 is equal to 0 divided by ln 2, x will be equal to 0. So the values are x has to be equal to 0 and x has to be equal to 1. So the crook method I used, which I made a mistake, but I found x to be equal to 0. It was correct. So I think you can solve this one and try to send me the answer. Okay. So now, if you have, I said you should solve this one, but I know even if I give you to say solve it, you will not even submit the answers. So let's go ahead and also verify the same one we solved together. So the question is 6 raised to the power 2x plus 1 minus 17 6 to the power that plus 12 is equal to 0. So if there is plus, meaning there was 6 raised to the power 1 and also 6 raised to the power 2x minus 17 6 raised to the power x plus 12 is equal to 0. Let y to be equal to 6 to the power x, meaning where there is a 6 to the power x we put y, so it will be 6y to the power 2 minus 17y plus 12 is equal to 0. Now that is a quadratic. Now I believe you can solve from there. So let's go ahead and see what's going to happen. So now I have got the product of 6 times 12, 6 times that one, 2, then 6 times 1 is 6, so it's 72. Then sum is negative 17. So what can be the factors? If you don't know the factors, you can just use them. You can use quadratic equation. Okay. So me, I'm not going to waste time to use quadratic equation. I'm going to find the factors. Yeah, I'm going to find the factors. So the sum is negative 17. So what can be the numbers? What can be the numbers? What can be the numbers? It should be negative 8. Yeah, negative 8 and negative 9. Because negative 8 times negative 9 is 72. Then negative 8 times negative 8 times 1 2 3 4 5 6 7 8, yes, 72. So the factors are neg 8 and neg 9. So I'll say 6y squared minus 8y minus 9y plus 12 is equal to 0. Factor out 2. Here I'm going to factor out 2y. I'll remain with 3y minus 4. Here I'll factor out 3. I'll remain with 3y minus 4. Meaning I have 2y minus 3 and 3y minus 4 is equal to 0. Then I have 2y minus 3. 2y minus 3 is equal to 0 and 3y minus 4 is equal to 0. So I shift that to the other side. It's going to be 3. So y is equal to 3 over 2. What of this one? Y will be equal to 4 over 3. Remember, these are not the answers. We had to let y to be equal to something. So what I'm going to do is I'll say we had to let 6x to be equal to y. So we have found that y is equal to 3 over the first one, 3 over 2. I can't make the base to be the same, introduce ln. Ln 6 raised to the power 6x is equal to ln 3 over 2. So the property of log allows us to shift the power to be in front. So it will be x ln 6 is equal to ln 3 over 2. Divide both sides by ln 6, even here by ln 6. So x, the first value of x is that ln 3 over 2 in the brackets divided by ln 6 in the brackets. So that's the first answer. The second answer is going to be it is 6 to the power x is equal to y. So 6 raised to the power x is equal to y is 4 over 3. Introduce ln, so it will be ln 6 raised to the power x is equal to ln 4 over 3. You can put them in brackets. The property of log allows us to shift the power. It will be like that. Now, if I'm to get rid here, this is going to be, I divide both sides by ln x, so x will be equal to ln 4 over 3 divided by ln 6. That's the answer. So the answer is this one and that one. So if you manage to find these ones, then that's okay. Let's go to question 13. Question 13 is saying solve for x in the following equation involving logarithm. Make sure you check for external solution. External solution, these are solutions. When you find the value, when you plug in the values, you discover that it's not making sense. It is going to give you undefined, but initially you are from solving. Okay, so what we are going to do is I'll start with the first one. So I can now, since I have solved those other ones, to create space, I will do it like that. So it is log base 2 log base 2 of 3x minus 4 is equal to 4. This is very simple. In this case, just change this to exponential. That will be easy. So exponential, you get the power, the base raised to the power what is outside is equal to what is inside. 2 raised to the power 4 is equal to 3x minus 4. 2 raised to the power 4 is 16. 16 is equal to 3x minus 4. Shift this to the other side, it will be 16 plus 4 is equal to 3x. If we add these two, they will give me 20 is equal to 3x. Divide it by 3, x is equal to 20 divided by 3. Now we have to check the answer. Is the answer correct? 2 base 2, 3x minus 4 is equal to 4. Where there is x, if I plug in 3, or I plug in 20 over 3, 3 and 3 will go, so it will be 20 minus 4, which is 5. 20 minus 4 is 16, which is 16 is equal to 4. This can be written as 2 raised to the power 4, 16. So it will be log 2, then 2 raised to the power 4. Shift the power to be in front, so it will be 4 log 2 of 2. This is going to be 1, so it will be 4 is equal to 4. So x is equal to 20 over 3 is indeed the correct answer. That is the same for part 2, where you can just change to exponential, where you are going to say the base is 10, so you say 10 raised to the power 2 is equal to what is inside, which is this. This is going to give me 100 is equal to x minus 4. Shift 4 to the other side is going to be 100 plus 4 is equal to x. Therefore x is equal to 104. If we put there 104 minus 4 is going to be 100 is correct. So the answer is 104. If we go to part 3, where it is saying ln x, Ln is always in base e, so it's going to be ln is going to be e raised to the power negative 3 is equal to x. Okay, now from here introduce ln to get rid of the e. So I'll introduce ln everywhere, so it will be e raised to the power negative 3 is equal to ln x. My goal is to find the value of x, so what I'm going to do, the property of log allows me to shift the power to be in front, so it will be negative 3 ln e is equal to ln x, but ln e is always 1. Ln e is 1, so meaning is negative 3 times 1 is equal to ln x. So it will be negative 3, let me just write it from here, negative 3 is equal to ln x. Divide both sides by ln, even here ln. So my x value will be equal to x will be equal to negative 3 over ln. But let's see where there is x, if we are to introduce, okay, yeah, it's making sense. It's making sense in such a way that where there is x, if I introduce its ln, where there is x we put negative 3 over ln, so ln and ln will go, so I have negative 3 is equal to negative 3. Yeah, it's correct. So x is equal to negative 3 over ln. We go to this one. If the bases are the same, what do we do? Last time I gave you this log a, if the bases are the same, log b is the same as you are just saying log, the base is the same, so you multiply this, it's going to be a times b. If there is minus, we don't have any question for minus. If there is minus, what we normally do is we divide the one having negative. For example, if we have log a minus log b, then this is log a divided by b, if there is minus and the bases are the same. So for that question, what we'll do is we'll say log base 3, we are going to multiply now x minus 3 multiplied by x is equal to 2. The property of log allows us to, or converting this to exponential, is 3 raised to the power 2 is equal to x minus 8 times x. So it will be 9 is equal to x squared minus 8x. So when you have got x squared and x, then there's a number, that's a quadratic equation. So it's x squared minus 8x, shift that to the other side, minus 9 is equal to 0. What's the product? The product is negative 9. The sum is negative 8. What are the factors? The factors is negative 9 and positive 1. So that when this time that is that, that time that is that. Meaning I've got x minus 9 and x. I have got x minus 9 and x plus 1 to be equal to 0. So x is equal to 9, another x is equal to negative 1. Now, let's go ahead and see. You can never have log of negative, it is undefined. So if I start now plugging the values, if I put 9, where there's x, inside it's going to be 9 minus 1, which is okay. There 9 is positive 9. But when I put negative, it's going to be negative 1 minus 8, which is going to give me negative 9. Then there is going to be negative 1. So meaning I've got log of negative 9, and there is going to be log of negative 1, which is undefined. Therefore, the only solution for this equation is that x should be equal to 9. X is equal to negative 1 is not the solution because it's giving me negative. Okay. The next thing what I'm going to do is part 5, which is saying log of x to the power 8 is equal to log x. Now everything raised to the power 4. This is also simple. What I'm going to do is I'll shift the power to be in front so that I remain with log. The base is the same, which is 10. That is equal to log of x to the power 4. When you reach at this point, just do this. Let y to be equal to log x, meaning that where there is log x, put y. So this is going to be 8. Y is equal to y. Now it's raised to the power 4. I'll put to the power 4. I'll shift this to the other side, so it will be y minus y to the power 4 is equal to 0. Then I can factor out y. So it will be y, okay, it will be y, open brackets, then I'll remain with 8 minus y to the power 3 is equal to 0. Meaning y is equal to 0. That's the first answer. Not the answer, which is going to help me to find the final answer. The next one is 8 minus y to the power 3 is equal to 0. Shift y to the other side, so it will be y is equal to, or 8 is equal to y to the power 3. Now I can get the cube root. If I get the cube root, even here the cube root, so the 3 and 3 will go, therefore y is equal to, the cube root of 8 is 2. So I've got two things. Now we had to let log x to be equal to y. So we'll say log x is equal to y. Now the first answer is 0, meaning it is 10 raised to the power 0 is equal to x. Any number to the power 0 is 1, so x is equal to 1 is the first answer. Another one I have to plug in. I have to plug in 2. So I'm going to say log of x is equal to 2, meaning it's going to be 2 or 10, but the base is 10. 10 raised to the power 2 is equal to x. So meaning x is equal to 10 to the power 2 is 100. X is equal to 100. So here nothing is going to be complicated, because if I put x to be equal to 100 is going to be positive. X is equal to 1 is going to be positive. So this is the answer, and also this is the answer. So these are the values of x. Now we can go further and also talk about this other question, which is question 5, which is saying log base 3 of x plus log base 3 of x minus 2 is equal to 1. So what I'm going to do is, the base are the same, so it's positive, then I'm going to multiply them. So I've got log base 3 of x, then x minus 2 is equal to 1. So this is going to be log base 3, x times x is x squared, then x times that one is 2x is equal to 1. So now we convert this to exponential. It is 3 raised to the power 1 is equal to x to the power 2 minus 2x, meaning I have now x squared minus 2x is equal to 3. Now this is a quadratic equation. Shift 3 to the other side. X squared minus 2x minus 3 is equal to 0. Product is negative 3. The sum negative 2. What are the factors? So the factors will be negative 3 and positive 1. For the fact that the coefficient here is positive, meaning x minus 3 and x plus 1 is equal to 0. So x will be equal to 3 and x will be equal to negative 1. So let's go ahead and identify if maybe we have extraneous solutions. So if I put where there is log, I put 3 is going to work out, it's going to be positive. But if I put -1, it's going to be -1. I can't have negative that is undefined. Therefore, this is not the solution. It's not part of the solution. It's an extraneous solution. The only solution is that x is equal to 3. We also do the last one for this part. So the last one for this part is ln x squared is equal to 16. So we are going to convert this to exponential. Ln is always to base e, so it is e raised to the power 16 is equal to x squared. The property of log, now I'm going to introduce ln to get rid of that again. So it's going to be like this, is equal to ln x squared. So the property of log allows me to shift this to be in front, so it will be 16 ln e is equal to ln x squared. So ln e is 1, so I'll have just 16 to be equal to ln x squared. Divide both sides by ln, even here by natural log. So we'll have x squared is equal to 16 divided by ln. Then what are we going to have? Okay, so what we are going to have is you get the square root, so this is going to be the square root of 16 over ln. So x will be equal, the square root of 16 is 4, and that one we don't know. Okay, so that is okay. So that is the answer for that last one. I think I can say we are done for question 13. Next we'll go and solve question 14. Let's do question 14. So question 14 is not complicated. It's more like it's in inequality actually. So for example, the first one, which is just direct, I'll shift 2 to go to the other side. I'll have this greater than -2. At this point, I'll also convert this into exponential. Or first I have to divide everywhere by 5, even here by 5, so that I remain with log x is greater than -5 over 2. -2 over 5, sorry. Then I'm going to convert this to exponential, where it's going to be x. Okay. 10, sorry. It's supposed to be the base, which is 10. 10 raised to the power 10 raised to the power -2 over 5 is equal to x. So initially I'm supposed to say it's greater than x, but I'll come back because I have to use inequality. Okay, I have to use inequality. So it's basically the same thing, where I'm going to say, so this greater than has to come to this one, so it's going to be x is greater than 10 raised to the power -2 over 5. So that will be the answer. Okay, so if you want, that is basically the same as x is greater than 1 over 10 raised to the power 2 over 5. You can leave it there. Question 14b, which is 2. This one is just direct, where we're going to say I'll shift 2 to come in front, so it will be 2 times 2, 4, log x minus 3 log x less than, then I have with this minus log 4x. From here, what I can do is I can just do minus here. I'll end up having log x then less than this one. I'll end up having this, the bases are the same, and these ones we can just divide them. We're going to have log 8x divided by 4x. So log x less than this. I'm going to have 8 divided by that. I'll have log 2 x, and x will go. So if the bases are the same, you can just cancel these and equate these things inside equal to each other. So you cancel the base or the log. So it will be x is less than 2. That's the answer. But let's think of this. We're saying that x should be less than 2. That's very true. But again, when we're talking about log can only be defined when x is greater than, like in this case, x has to be greater than 0, because I cannot have negative, meaning that x, if I just consider this to be the answer when I'm saying x is less than 2. So if I put any number less than 2 here, which is, maybe I put negative 1, it's going to be undefined. So I'm supposed to say the values of x should be starting from 0 all the way to 2. So this should be the answer. So I'll say 0 less than x less than 2. So this is the answer. The value of x. Question part 3, which is the last one. Now to make things simple, let's just do this. Let's let e to the power x to be equal to y. So let e raised to the power x to be equal to y, meaning here now I have got y minus 2, even here y minus 3 less than 2y. I'll shift y to go to the other side, then I'll have 2y, y minus 2, y minus 3 less than 0. So meaning the first one I've got 2y less than 0, another one 2 or y minus 2 less than 0, another one y minus 3 less than 0. So this would be y is less than, greater than, sorry, or less than, not greater than 2. Then this one will be less than 3. So if this one will be y, if I divide both sides by 2, less than 0. Now I've got these are my critical points. Okay, if I want, these are my critical point, I can make it. That is if I want. But let's do this. We had to let y to be equal to that one. So now what I'm going to do is I'll go ahead and make the table for these guys to find the critical, to find the values. So I'm going to have 0, 2, 3. So here it will be 4, here it will be 1, here it will be, no, here it will be 2.5, here it will be 1, and here it will be negative 1. We see the values which are going to be. So I'm going to put here, I'll put 2y. Here I'm going to put y minus 2. Then the other part I'm going to put y minus 3, like that. Let me just shift this one to be on top a bit, like that. So let us see, if I put negative here, negative 1, I'm going to get negative there negative, here negative, overall will be negative. Overall will be negative. If I put positive there, is positive, there positive, positive 1 is going to be still negative, here also negative. When I put y where there is 1, so it's going to be negative. Overall, or this is positive, sorry, overall will be positive. If I put 2.5 there, it's going to be positive. 2.5 here is going to be negative, positive. 2.5 there, negative, overall negative. If I put 4 there, positive, here positive, here positive, overall positive. Now, one thing we need to understand is this. This is less than, so I'm going to get the ones having negative, which is this one and that one, which is, we are saying, so it's going to be from y is less than 0, which is okay, yes, and also y is less than 2, then also less than 3. So it's more like I'm getting 2 to 3, yes. So I have y is less than 2, but again, it's more like I've got 2 less than y and less than 3, that one. And also y is less than 0, like that. So what I'm going to do now from here, after doing this, but I think it was not even necessary for us to do the table, but you can also waste time like the way I've wasted time here. You can just find the way we have found these ones, then you come here and say, we had to let y to be equal to, or yes, we had to let y to be equal to e to the power that. So we are going to come back here and say e raised to the power x. So I'll put, now I want to put 3, I'll start with 3, or let me start with 0. So I'll say it is less than 0. Now I want to find the value of x. Introduce ln less than 0. So here the x will drop, we'll have this, then less than 0. So my x will be less than 0 still, because I'll divide both sides by 0. That's the first one. Another one, it will be e raised to the power x is equal to 2. Then we'll introduce ln e raised to the power x is equal to 2. Or it's going to be less than now in this case. It's going to be less than 2. So it will be ln, I'll drop x, so it will be x, it will be x ln e less than 2 divided by ln e, but ln e is 1, so it's still x will be less than 1, or it will be less than 2. Again, I'll just come back to this. These answers I've found here, I don't think there is any problem. Okay, so x is less than 2. Again, if I go for 3, it's going to be x is less than 3. Then now the final answer is going to be this. So the x value, you put it in set interval notation. You are starting from, we have said y is less than 0, so it's starting from negative infinity to 0, and then union, these ones, they're just starting from 2 all the way to 3. So this is the final answer for the last one. So you can either use the table is just wasting time. You can just come direct there, then plug in x. So that's the answer.